This is SpaceTime, Series 22, Episode 40. Coming up on SpaceTime, the incredibly shrinking moon causing moonquakes, a new way to form volcanoes, and a meteor lights up the night skies of outback Australia. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that moonquakes are being generated as the moon continues to cool and contract. A report in the journal Nature Geoscience claims the moon is shrinking as its interior cools, getting over 50 meters skinnier over the last few 100 million years. The brittle lunar surface crust breaks as the moon shrinks, forming wrinkles known as thrust faults. That's where one section of crust gets pushed up over a neighbouring section. What's left behind are fault scarps, resembling small step-shaped cliffs when seen from the lunar surface, typically a few tens of meters high and extending for several kilometers. Astronauts Eugene Cernan and Harrison Schmitt had to zigzag their lunar rover up and over the cliff face of the Lee-Lincoln fault scarp back during the Apollo 17 mission, which landed in the Taurus-Lithrow Valley back in 1972. The study's lead author, Thomas Waters from the Smithsonian National Air and Space Museum in Washington, says this new study is providing scientists with their first evidence that these faults are still active today and likely producing moonquakes as the moon continues to gradually cool and shrink. Of course, the moon isn't the only world in the solar system experiencing shrinkage with age. Mercury has enormous thrust faults, up to 1,000 kilometers long and over 3 kilometers high. That's significantly larger relative to its size than those on the moon, which indicates it shrunk much more than the moon has, even though they're similar in size. Waters and colleagues analysed data from 4 seismometers, which were placed on the lunar surface by Apollo astronauts, using an algorithm specifically developed to pinpoint quake locations detected by a sparse seismic network. Astronauts had placed the instruments on the lunar surface during the Apollo 11, 12, 14, 15 and 16 missions. The Apollo 11 seismometer only operated for 3 weeks, but the 4 remaining recorded 28 shallow moonquakes between 1969 and 1977, and the quakes were the exact type expected to be produced by these faults. The moonquakes ranged from about 2 up to 5 on the open-ended Richter scale. The algorithm has given a great estimate of moonquake locations. The seismometers measured the shaking produced by quakes, recording the arrival time and strength of various quake waves in order to get a location estimate called an epicenter. Using the revised location estimates from the new algorithm, the authors found that 8 of the 28 shallow quakes were within 30 kilometers of faults visible in lunar images. Now that's close enough to tentatively attribute those quakes to the faults, since the authors' modelling showed that this is about the right distance over which strong shaking is expected to occur given the size of the fault scarps. Interestingly, the new analysis also found that 6 of these 8 quakes happened while the moon was at or near apogee, its furthest orbital position from Earth. The authors say this is where additional tidal stress from the Earth's gravity causes a peak in the total stress, making slip events along these faults more likely. The authors ran 10,000 simulations, calculating a less than 4% chance of a coincidence producing that many quakes near the faults at the time of greater stress. Now, other events such as meteoroid impacts can also produce quakes, but they produce a very different seismic signature than the quakes made by fault slip events. Other evidence that these faults are active comes from highly detailed images of the moon from NASA's Lunar Reconnaissance Orbiter spacecraft. The probe imaged more than 3,500 of these fault scarps. Some of these images show landslides or boulders at the bottom of relatively bright patches on fault scarp slopes. And the thing is, weathering from solar and space radiation gradually darkens material on the lunar surface. Now that means the brighter areas are regions that are relatively freshly exposed to space, which is exactly what you'd expect if a recent moonquake sent material sliding down a cliff. Other images show clear tracks from boulder falls, what you'd expect if a fault had slipped and the resulting quake sent boulders rolling down the cliff slope. Now, these tracks are all evidence of recent quake activity, because otherwise they would have been erased fairly quickly in geologic time by that constant rain of micrometeoroid impacts on the moon. One of the revised moonquake epicenters is just 13 kilometers from the Lee-Lincoln scarp traversed by the Apollo 17 astronauts. The astronauts also examined boulders and boulder tracks on the slope of the North Massif near the landing site. A large landslide on the South Massif that covered the southern segment of the Leo-Lincoln Scarp is further evidence of possible moonquakes generated by fault slip events. Now, all this is a great example of how data from nearly 50 years ago and from more recent Lunar Reconnaissance Orbiter images have been combined to advance science's understanding of the Moon. The Lunar Reconnaissance Orbiter has now been photographing the lunar surface since 2009, and the authors want to compare images from specific fault regions from different times to see if there's any evidence of recent moonquake activity. Establishing a new network of seismometers on the lunar surface will undoubtedly be a priority for future human exploration of the Moon. This would allow scientists to both learn more about the Moon's interior and determine how much of a hazard moonquakes present. NASA says humans will be going back to the Moon in 2024. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Let's talk about moonquakes, Fred, because they have basically used technology from, I think it was about 4 Apollo missions to analyse what's happening on the Moon, and basically she's doing a bit of a shimmy.
Indeed, that's right. So we've kind of known about the moonquake really since the Apollo era, because I think it was for 9 years those seismometers that were left on the Moon by the Apollo astronauts. And you're quite right, it was 4 of those missions. There were 6 missions that actually had astronauts walking on the Moon. 4 of them deployed seismometers. So during that period of 8 or 9 years, which was the time that these instruments remained active, which is pretty good going because they were all solar powered. They probably had batteries, were 1969 quality batteries. They wouldn't be all that brilliant. And they lasted for that time and sent back copious quantities of data, thousands of moonquakes. And by the technology of the day, you could kind of triangulate between the different seismometers. You've got 4 of them on the near side of the Moon. They're not very far apart because they're all kind of in the equatorial latitudes of the Moon and they're all on the near side. And it's by having seismometers a long way from each other that you can really see what's going on inside the planet. We use it on the Earth all the time. And on the Moon, thousands of moonquakes were detected. But because of this fairly close separation of the seismometers, it wasn't really possible to locate them, particularly the shallow ones. The deep ones you could get a handle on, and we believe that the Moon's interior is still cooling down, and that's what causes the deep moonquakes. But it's taken until now to really find out what's been going on with the shallow ones. And it comes about because of another NASA project, kind of 50 years later, not quite actually, I think it's been in orbit around the Moon for probably the best part of a decade already. Lunar Reconnaissance Orbiter is a NASA spacecraft. It orbits the Moon. It's done the most magnificent high-resolution imagery of the Moon's surface. What Lunar Reconnaissance Orbiter has done is allowed fine-resolution imagery of the surface, of the natural features on the surface. And what they've done, the scientists who are running the show, is that they've found all these youthful-looking fault scarps. You know what a fault is? It's when the land slips vertically with respect to the other half. There's a line that divides 2 bits of land and one is slipped vertically with respect to the other, and you get a fault. We've got many of them in Australia.
Yeah, we have. They're all over the world.
Yeah, indeed, that's right. They look youthful from the imagery, and by that I mean that their edges are sharp. You've got something that's obviously moved within the recent past, and erosion, because erosion does take place on the Moon, even though it's very slow, hasn't had time to round all the edges off. Old features tend to be more rounded. These look quite young. But what is the clincher on that is that it was Apollo 17, the final Apollo mission, crewed by Gene Cernan and Harrison Schmitt. They saw one of these faults when they were on their Apollo 17 mission, and they actually drove to it with their moon buggy and grabbed some rock samples. And those rock samples showed that it was a very young structure, that the scarps probably were younger than 10 million years. And that's young in geological time.
Certainly young in astronomical.
Yeah, it's young by comparison with us as well, but it's quite useful. So there's this clinching set of evidence. The Apollo guys found the rock by one of these young-looking faults and demonstrated that, yes, it is young-looking. But now knowing where these faults are because of the Lunar Reconnaissance Orbiter survey, the mission scientists for that have identified, I think, 3,000 of them. It's a huge number. And what they've now done is built that knowledge into the records of the seismometers that Apollo left on the moon. And sure enough, it turns out that you can actually locate many of the tremors to these fault areas. It's a lovely piece of science with data separated by 50 years almost. But it actually demonstrates that there is tectonic activity happening on the moon, because these moonquakes, far from being mostly caused by meteorites, which is what everybody expected, because people expected the moon to be tectonically dead, just nothing happening there, nothing to see, please move along. It's not like that at all. It looks as though the moon's surface is still active. And what is thought to be causing that activity is the shrinkage of the moon as its interior cools. So as the moon cools, it gets smaller because it's contracting. And that contraction actually causes the fault lines on the surface and gives you these moonquakes. There is one other piece of clinching evidence with this, Andrew, which I've failed to mention so far, and that is that these things were more common when the moon was at its nearest and farthest points from the Earth. And those are the points where you've got the biggest tidal stress on the moon.
Oh, so it's a combination factor. So it's the shrinking of the moon and its position in proximity to us in terms of its gravitational effect.
So what you've probably got is the moon shrinking all the time, but it takes a little bit of an extra bit of stress to push the fault into a little bit of slippage. That then gives rise to the moonquake.
Wow.
Very nice science indeed. And I think it reveals a mystery, actually, because the current thinking has been that the moon is cold and dead. Its interior really doesn't have anything going on inside, nothing molten like we've got in the center of the Earth. Remember, the moon's only a quarter of the diameter of the Earth, so it would have cooled much more quickly. And yet it's still got enough heat that it's losing that heat and causing the contraction. So the mystery is, where is the moon's interior heat coming from? It sounds as though there's more heat coming from the moon's interior than we expected. And maybe that might give rise to another moon mission, a bit like InSight, which has a temperature probe on it, which is currently stuck, I think, as it tries to burrow down into the ground. But the temperature probe is designed to show how much heat's coming from the interior of Mars. You could do the same sort of thing on the moon. I hope NASA is listening to Space Nuts, because we're full of ideas for future.
I often send it to them. I do. I
bet you never get a reply.
Not really, but I never expect one. Is it possible that the activity of Earth being a bigger body is perhaps causing a friction effect inside the moon and heating it up? Like you look at how the gas giants impact on their moons, and some of them are quite volatile because of
yes, that's right. So
the gravitational effect.
Yes, so you're thinking of Jupiter and its moon Io, which is the most volcanically active body in the solar system because of the gravity of Jupiter being right next door. Yes, there's I'm sure there's an element of that, because we know that the tidal effect of the Earth is actually imparting energy to the moon. The Earth itself is giving up rotational energy, which is why we need leap seconds every now and again. And that energy is going into speeding up the moon. So there are definitely forces at play there which could indeed be contributing to that. I think that's locked up in what we were talking about, the fact that the moon is nearer and further away from the Earth at different times in its orbit. Plate tectonics on the Earth is unlikely to have any direct influence on the moon. It's got much more of an influence on what goes on here. And that's why we can't see ancient craters on the surface of the Earth, because, at least not terribly ancient ones, because they've all been rubbed out by plate tectonics.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Scientists have discovered a new way to form volcanoes. A report in the journal Nature claims geoscientists have discovered the first direct evidence that material from deep within the Earth's mantle transition zone, a layer rich in water crystals and melted rock, can percolate up to the surface to form volcanoes. Scientists have long known that volcanoes form when tectonic plates, travelling on top of the Earth's mantle, converge. Volcanoes can also form as a result of mantle plumes that rise from the core mantle boundary to make hotspots in the Earth's crust. But obtaining evidence that material emanating from the mantle's transition zone between 440 and 660 kilometres beneath the planet's crust can also cause volcanoes to form is new to geologists. The study's lead author, Associate Professor Esteban Gazelle from Cornell University, says it's the first time that researchers have found any clear indication from the transition zone deep in the Earth's mantle that volcanoes can form this way. Gazelle and colleagues were studying the formation of the island of Bermuda. They were expecting the data to show that the volcano which formed the island was a mantle plume formation, an upwelling from the core mantle boundary, just like Hawaii. But it turned out, about 30 million years ago, a disturbance in the transition zone caused an upwelling in the magma material to rise to the surface, forming a now dormant volcano under the Atlantic Ocean, and then forming Bermuda. Using a core sample more than 700 metres long, which had been drilled in 1972 and stored at the Dalhousie University, Nova Scotia, study co-author Sarah Mazur from the University of Munster in Germany assessed the cross-section for isotopes, evidence of water content, and other volatile materials. This assessment provided a geologic volcanic history of Bermuda. Mazar suspected that Bermuda's volcanic past was different from what was expected when she sampled the core and noticed the diverse textures and mineralogy preserved in the different lava flows. The authors quickly confirmed extreme enrichments in trace element compositions. From the core samples, they detected geochemical signatures from the transition zone, which included larger amounts of water encased in the crystals than what's usually found in subduction zones. See, water in subduction zones recycles back to the Earth's surface. But Gazelle says there's enough water in the transition zone to form at least 3 oceans, and that helps rocks melt in the transition zone. The authors then developed a numerical model which indicated disturbances in the transition zone that likely forced material from the steep mantle layer to melt and then percolate up to the surface. So these findings are providing a new connection between the transition zone layer and volcanoes on the Earth's surface. And as scientists look more carefully, they suspect they'll probably find more of these geochemical signatures in more places. You're listening to Space Time. I'm Stuart Gary. A meteor has lit up the night skies of the Australian outback, with witnesses reporting a flash of light briefly turning night into day. The celestial light show was seen just after midnight across the Northern Territory's Red Centre, with reports coming in from as far north as Tennant Creek. But it was 500 kilometres further south in Alice Springs, where residents reported not just seeing the bright flash, but also hearing a rumble that shook windows. Witnesses reported a streak of purple light lasting about 5 seconds, together with a massive thunderous noise and rumbling like an earthquake, and then a sudden brilliant golden yellow flash. The Bureau of Meteorology suggests the meteor was part of the annual Eta Aquarids meteor shower, generated as the Earth passes through the dust and debris trail left behind by Halley's Comet. Now, if you're a regular listener of Space-Time, you'll know that the Eta Aquarids often produce bright yellow meteors, which often appear as streaks radiating out from the direction of the constellation Aquarius and the star Eta Aquarii, hence the shower's name. These meteors are best seen coming from the east after midnight and before dawn. I'm Stuart Gary, and this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. In what some are calling a major milestone for artificial life, scientists have created living colonies of E. coli bacteria using DNA constructed by humans, not nature. The researchers rewrote the bacteria's DNA, fashioning a synthetic genome larger and far more complex than anything previously created. 9 years ago, researchers constructed a synthetic genome about 1 million base pairs long. But this new bacteria uses 4 million base pairs. A report in the journal Nature says the bacteria operate according to a new set of biological rules, producing familiar proteins with a reconstructed genetic code. Outwardly, the new bacteria is unusually shaped, but they are reproducing, though at a slower than normal rate. Each gene in a living genome is composed of combinations of 4 molecules: adenine, thymine, guanine, and cytosine. These are known as bases, and they're usually referred to by the letters A, T, G, and C. A gene could be made up of thousands of these bases. And it's the genes which direct cells to choose among 20 amino acids, which in turn are the building blocks of proteins. And proteins are the workhorses of cells, carrying out vast numbers of tasks in the organism, from transporting oxygen in the blood to generating force in muscles. The production of each amino acid in the cell is directed by 3 bases arranged in the DNA strand and known as a codon. There are 64 known codons, which are used to encode the 20 known amino acids in the genetic code. For example, the production of the amino acid serine takes 6 different codons, one of which, TCT, ensures that serine attaches to the end of a new protein. As well as these, there are further 3 so-called stop codons, which tell DNA where to stop construction of an amino acid. Now, all this research is offering new clues as to how the genetic code arose, and may lead to new organisms producing medicines or specific molecules. New research claims men are continuing to use steroids in pursuit of a body beautiful. That's despite warnings about the potentially lethal or life-limiting side effects. A report tabled at the European Congress of Endocrinology found 30% of men who regularly visit the gym were steroid users, and 70% of users admit they were aware of the side effects. Anabolic steroids such as testosterone are used to enhance performance by increasing muscle mass and boosting athletic ability. But the side effects can be quite disastrous. They include heightened aggression, reduced sperm count, erectile dysfunction, baldness, breast development, and an increased risk of heart disease, stroke, and liver or kidney failure. A survey of plastic pollution on Australia's Cocos or Keeling Islands in the Indian Ocean has revealed the territory's beaches are littered with an estimated 414 million pieces of plastic debris. That's some 238 tons of plastic, including 977,000 shoes and, surprisingly, 373,000 toothbrushes. You can read all the details in the journal Scientific Reports. A new study has found that half of the Internet's most popular websites are at risk of malicious activity. The research by the CSIRO found the problem is that most sites depend on a chain of third parties to import external resources, such as ad providers, tracking and analytics services, and content distribution networks. Now, these are often required to properly load the content. Scientists found that these third parties can often load resources from other domains, creating a dependency chain which can be more than 30 domains in length, all of which is underpinned by a form of implicit trust with the original website. What the CSIRO found is that the larger this dependency chain, the greater the threat of malicious activity. Researchers found that although the problem is well known in the industry, its implications on security and privacy are often overlooked. The thing is, almost all websites today are heavily embedded with tracking components. For every website you visit, no matter how careful you are, you're leaving a trail of your internet activity. And you could unknowingly be loading content from potentially malicious parties. In fact, the researchers found that some 1.2% of third parties linked to the top 200,000 websites are suspicious. Amazingly, the popular web resource JavaScript, generally used to improve the user experience of the web, represents the greatest risk of malicious activity. That's because they're designed to be executed undetected. A new study has found that parents aged between 22 and 37 were the most likely to be on their phones while driving. The findings, reported in the Journal of the American Medical Association, found that those over 37 were still using their phones in their car, but it was the younger, apparently more tech-savvy bunch that were doing the most reckless things, such as writing emails, checking maps, and playing on Facebook and Instagram while behind the wheel. However, the researchers admit their study may be skewed. That's because old fogies above the age of 37 may well be less able to use the internet in order to answer their survey. The credibility of the Southern Cross University has come into question after it's announced courses in naturopathy. The courses are being funded through a $10 million grant by a major naturopathy and vitamin company. The university's reputation has been further damaged by research it coincidentally published claiming the health benefits of naturopathic treatment. However, the study doesn't look at all of naturopathy. It only focuses on the more conventional aspects of the therapy, such as good clinical nutrition, a healthy diet and lifestyle, all of which is just perfectly good, simple mainstream medical advice, not naturopathy. The study conveniently avoided looking at the more wacky, Looney Tunes side of naturopathy, such as homeopathic treatments, which lack any peer-reviewed scientific evidence supporting them. Professor John Dwyer from the University of New South Wales and former president of Friends of Science in Medicine has also questioned the study's definition of naturopathy. He says there's been a standoff between Southern Cross University and the rest of the scientific community for a number of years, and there have been challenges as to whether they really are holding up the highest standards of evidence-based medicine. Tim Mendham from Australian Skeptics says Southern Cross University's actions are concerning.
Now, naturopathy is a bit of a mishmash of medicines and folk cures and that sort of stuff. There's a lot of spiritualism in there almost. It basically goes from pretty straightforward advice like eat well, eat the proper foods, rest, etc., all the way through to energies that impact everything you do, to the body has a self-healing spirit. I mean, it's sort of almost like a abstract spirit that actually impacts on your life. The university is seeing itself as a bit of a centre of naturopathic medicine and research and education in these areas. Some academics at the university put out a paper suggesting that naturopathy works. It's got peer-reviewed evidence to prove that it does.
Does it actually have peer-reviewed evidence to prove that it does? Because my understanding is it doesn't.
That's the whole problem. The issue is that the evidence they put forward and the treatments they were talking about were by and large pretty mundane. Eat the proper foods, have rest, etc. And that's not naturopathy. That's just
common
good
sense.
Common sense advice. And it's all the other areas, the spiritual forces, the energies, unknown energies, and all sorts of strange products. And they have a lot of strange products that are being promoted in naturopathy. They ignore that by and large. So this research by this group in Southern Cross University has been heavily criticised for being a bit naive, for being a bit superficial, and for claiming areas that are common sense and part of everyday medicine and everyday lifestyle as something special to naturopathy, and it's not. So they're going to have to go a long way to provide better evidence than that.
How do they get away with this? There are no standards in Australia to stop this sort of thing?
Funny you should say that, because that's actually the feature of our next issue of the magazine.
Oh, okay.
Our Skeptic magazine is about academic freedom, basically, which is a very...
We've just had a court case on that in northern Queensland, haven't we?
Yes, that's right. And that was, that's the opposite. That was someone who was criticising climate change and criticising the university's attitude towards it. And the university was asking him to, well, for various reasons, and we'll go into that in detail in the article, to actually that he should be less vocal in some of the criticisms he's using. Climate change deniers obviously said that that's censorship of free speech areas.
Yes, I've actually watched that guy being interviewed, and you can ask him a direct question, and he doesn't answer it directly. He then immediately goes on to justify his argument by looking at one very small area of a much bigger topic, because that one small area tends to support his viewpoint, whereas he doesn't have the holistic view of what's happening with the reef.
Yeah, I mean, I know it's about the barrier reef, etc., and that was what his area. The issue with the classic one is the PhD at the University of Wollongong.
Wollongong, yes.
Which was highly polemic from an anti-vaccination point of view, and it's been highly criticised. I mean, really rubbished left, right and centre, both within the university, within the Wollongong University, within the academic community generally, and much, much broadly than that. But the university has said, oh, well, yeah, freedom of speech. And you think that's lack of quality control of a university, and that's happened in a number of cases.
It's belittled the University of Wollongong's credibility. Yeah. I think the other important point about this story too is that Southern Cross University, their Lismore campus, is sort of the Australian epicentre of the hippie movement. Everyone smoking a bit of weed and getting a bit stoned, and we want to say everyone, not everyone, but it is a centre in Australia to which people of an alternative culture tend to gravitate.
And that area, the Northern Rivers area of New South Wales, which is Byron Bay, that sort of area, Lismore has the lowest rate of vaccination anywhere in Australia.
That's the next
and it has some of the and has the highest rate of communicable diseases that can be treated with vaccination. When you get kids dying of whooping cough up there, and all sorts of diseases, outbreaks of measles, you name it, and largely because of this anti-vaccination movement up there that's based up there, you realise that it is a bit of a hotbed of alternative thinking.
Well, luckily, natural selection will take care of that problem in the long run. The genetic pool will clean itself.
It tends to do that, but unfortunately people have a lot of influence. After all, if these are university academics who are supporting naturopathic treatments, etc., on some fairly questionable arguments and evidence, then that has a wider spread than beyond the Northern Rivers area of New South Wales.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.